Now here the question is, if f is a set of all onto functions from a to b. Now in this set A we have n elements, a1, a2, an, and in this B we have 3 elements which are x, y and z, and f belongs to f is chosen randomly. What is the probability that f inverse x has 2 elements in it? And second part is f inverse x is a singleton. So basically here we are not talking about inverse function per se. Since it will be a many-one function, it cannot have inverse function defined for it. So basically what we are looking for is pre-images of x. So for the first part it says this x has 2 pre-images, and for the second part it says it has only 1 pre-image. Now for this, first what we'll do is we'll find number of onto functions which can be defined from this set A to set B. So we have to find total number of functions that can be defined. So what we'll do is from total we'll subtract all those cases in which at least one of the element is missing. So for each element we have 3 choices. So total number of functions that can be defined from A to B, it will be 3 to the power n. Now minus this first case when x is missing, so it will be this 2 to the power n. For y is missing, again 2 to the power n. For z is missing, 2 to the power n. So it will be this 3 into 2 to the power n minus this case when 2 of them they are missing. If xy is missing, all of them they go to z. So it will be this minus 3. So total number of onto functions from A to B will be given by 3 to the power n minus 3 into 2 to the power n plus 3. Now for this first one, now f inverse x has 2 elements in it. Now which 2? So from these n, we can select any 2 in NC 2 ways. Now these 2, they are mapped to x. Now remaining n minus 2 elements, they must be mapped to y and z, and it must be an onto function. So total number of functions is 2 to the power n minus 2 minus 2 cases when all of them they are either mapped to y or they are either mapped to z. So this required probability, it will be nc2 2 to the power of n minus 2 minus 2 divided by 3 to the power n minus 3 into 2 to the power n plus 3. And then the second case where this x has only 1 pre-image. So for the second part, we have to select 1 pre-image, it is nc1, and then for the remaining n minus 1 elements, we have to define an onto function from A to y and z. So it will be 2 to the power of n minus 1 minus 2. So this required probability will now be nc1 2 to the power of n minus 1 minus 2 upon 3 to the power n minus 3 into 2 to the power n plus 3. And that is the answer to this question.